Hello everyone, in this video we'll be doing the CBSE Class 9th Science Chapter 5 Exploring Mixtures and Their Separation. This is as per the new NCERT textbook Exploration. Let us start by understanding how we classify mixtures. Mixtures are classified into two types: homogeneous mixtures and heterogeneous mixtures. A homogeneous mixture is a well-stirred mixture that has the same composition throughout. It is also called a solution. For example, salt or sugar water solution, vinegar, which is basically acetic acid and water solution, soda, which is carbon dioxide and water solution. And a heterogeneous mixture is a stirred mixture that has different composition and components do not mix together, like sand and water or oil and water. Let us deep dive into understanding solutions. Solutions consist of two parts: solute, the substance that gets dissolved, and solvent, the substance that dissolves the solute. The amount of solute dissolved in a given amount of solvent or solution is termed as the concentration of the solution. There are three ways in finding out the concentration of a solution. First is the mass by mass percentage, which is how many grams of solute is present in 100 grams of solution. So mass by mass percentage is given by mass of solute by mass of solution into 100. It is usually used in the labels of our food articles that we see. Let us solve a numerical example to understand this better. If 20 grams of sugar is mixed in 120 grams of water, calculate the mass by mass percentage of the solution. So here the mass of the sugar, which is the solute, is 20 grams. Mass of water, which is the solvent, is 120 grams. Mass of solution, which is mass of solute and solvent, is 20 plus 120, which is 140 grams. So the mass by mass percentage will be mass of solute, which is 20, divided by the mass of solution, which is 140, into 100, which is equal to 14.28%. Next, we have the mass by volume percentage, where we see how many grams of solute is present in 100 milliliters of the solution. So mass by volume percentage is given by mass of solute divided by the volume of solution into 100. This is usually used or seen in top of IV liquids that are given, where it is a 0.9% mass by volume solution of sodium chloride and water. That is, for every 100 ml of solution, you have 9 grams of sodium chloride. We can solve an example to understand this better. If 50 grams of salt is dissolved in water to make 250 grams of solution, calculate the mass by volume percentage of the solution. So the mass of salt here, which is the solute, is 50 grams and the mass of solution is 250 ml. Mass by volume percentage will be mass of solute by volume of solution into 100, which is 50 by 250 into 100, which is 20%. Again, the third method is volume by volume percentage. Here, how many milliliters of solute is present in 100 milliliters of solution is what we know. This is mainly used in our perfume bottles in making solutions such as vinegar or perfumes, etc. Volume by volume percentage is given by volume of solute divided by volume of solution into 100. So, solving a question on this, if 25 ml of peppermint oil is dissolved in a solvent to make 200 ml of perfume, calculate the volume by volume percentage of the peppermint oil in the perfume. So the peppermint oil, which is the solute, is 25 ml and volume of the perfume is just the solution is 200 ml. Volume by volume percentage, which is volume of solute by volume of solution into 100, is given by 25 by 200 into 100, which is equal to 12.5%. This is how we calculate the concentration of the solution. Let us move to understanding what is the solubility of a substance. Solubility is the maximum amount of solute that dissolves in a fixed quantity of solvent at a given temperature, and this is called its solubility. A saturated solution is a solution that cannot dissolve any more solute at a given temperature. If we observe this graphically, where we have a graph of temperature on the x-axis and solubility of a solute per 100 grams of water for two compounds, compound A and B, this is how the graph looks. This is called a solubility curve, where the graph of solubility varies with temperature. We can clearly see that for compound A, as the temperature increases, the solubility increases, and for compound B as well, the solubility increases but at a much faster rate. Now, let us move to understanding another homogeneous mixture, which is an alloy. Alloy is a homogeneous mixture of metal and a metal, or a metal and a non-metal, and it is made through heating metals or non-metals at a high temperature and cooling it to form a single metal. They are more rigid, stronger, and more corrosion resistant. The examples we see above these are brass, bronze, construction steel, and stainless steel. All of these are alloys of different metals and non-metals. Moving on, let us understand the methods of separation for a homogeneous mixture. Starting with crystallization. A crystal is a solid that is made up of particles that are arranged in a regular geometric pattern, such as copper sulfate crystals or even snowflakes. Using the temperature variation of solubility, the process of forming crystals from a saturated solution is called crystallization. The process here is we make a saturated solution of the compound at a higher temperature and then cool the solution down to the lower temperature, so the remaining amount of solute becomes crystals. The principle we use here is based on the differences in the solubility of a substance at different temperature. This is used mostly when there is separation of two solids which are soluble in the same solvent. It can be used to purify some of the solids. This method is mostly used for rock salt crystals from seawater or sugar crystals from sugarcane. Moving on to the next method, we have distillation. Here, two miscible liquids which can be mixed together are heated, such as water and acetone or water and acetic acid, heated together to a certain temperature until vapors arise. And the vapors of the lower boiling point liquid are passed through the condenser, where they are cooled and collected in another vessel. The process here is the liquid is heated and the vapor is cooled, and the cooled vapor becomes liquid again, which is called the distillate. This is based on the principle that each liquid has different boiling points. It is used for the separation of two miscible liquids whose boiling points differ at least by 25 degrees centigrade. It is mostly used in extraction of perfumes from flowers or during petroleum refinery from crude oil. Moving on to paper chromatography. Here, the mixture is placed on the paper and the paper is dipped on the solvent. The separated compounds of the mixture appear on the paper as they pass through. The principle used here is the difference in the interactions of components with the solvent and the paper to separate them. It is mostly used for separation of mixtures containing different colored pigments. Sometimes this technique is used to find the different pigments of chlorophyll of a green leaf. Let us move to understanding the methods of separation of a heterogeneous mixture. Heterogeneous mixtures are sometimes separated by physical properties of the mixture, such as density, magnetism, weight of the particles, etc. Such as oil and water can be separated using a separating funnel, where the water, because of the density of the oil stays on top and the water is below, and the water is collected from the below. We can separate sulfur and iron fillings by using a magnet. The air is generally purified using an air purifier which contains different kinds of seals that purifies the air. So these are the different ways we can separate heterogeneous mixtures. Another process which can be used is called sublimation. Sublimation is the process of changing from solid state to gaseous state without passing through the liquid state. And deposition is the process of changing from gaseous state to solid state without passing through the liquid state. Examples of this are dry ice, camphor, and naphthalene balls. So if camphor is mixed with sand, we can heat it to make it sublime and then use the deposit, collect the camphor back. Moving on to different types of heterogeneous mixtures. There are two types of heterogeneous mixtures. One is a suspension and the other is a colloid. Let us look at the differences between them. In a colloid, the particles are of smaller size and we cannot see them with naked eye. Whereas in a suspension, the particles are of larger size and we can see them with the naked eye. The particles of colloid cannot be separated through filtration, whereas in suspension, we can separate them using filtration. In a colloid, the particles do not settle after some time, whereas the particles settle after some time in a suspension. Examples of a colloid are blood, milk, fog, butter, etc. And suspensions are muddy water, chalk water, etc. Let us see how colloids can be separated, starting with centrifugation. When an object is moving in a circular motion, we know that there is a centripetal force or centrifugal force that pushes the object inwards. But the object feels it is being pushed outwards. So when an colloid is placed in the test tube and is put into the centrifugal machine, the test tube becomes horizontal and the heavier particles move outwards and the lighter liquid stays on top. This helps in separation of colloidal particles, mostly used in separation of blood and its components. Next is coagulation. Any coagulant that is added to a colloid causes the suspendal particles to clump together. This process is called coagulation, and this is mostly used in the making of cheese or paneer, where lemon water is added that causes all the milk particles to clump together, leaving away the whey. Moving on, let us understand what is a Tyndall effect. The scattering of light by the particles in the solution is called a Tyndall effect. We can see this happening through canopy of trees every day or in floodlights, etc. A solution does not have Tyndall effect, whereas a colloidal and suspension, because of larger particle size, does show Tyndall effect. This completes the chapter of mixtures. Hope you have understood this chapter. Like and subscribe to this channel, solve all the questions behind the textbook, and you can comment below if you are stuck anywhere.